me. Anyway, so here we go. We are looking at power series, which we have been looking at before. And we are now looking at the domain. And the domain, why do I keep misfinding that word? So you know, as you plug values into X, when you plug a number into X, you create an infinite series of constants. And for those constants, some of them will create converge, some will create diverge. I've finally found the word. There it is. I don't know why I can't find words when, oh, it's also because I can't wear my glasses right now, and I have a much harder time seeing without them. But if I wear them, they will fog up, and that's worse. Some of you glasses folks understand, right? Okay. Domain of a power series is the set of all X for which the series converges. Boom. That is the domain. And we're going to learn how to find that domain. And that domain is going to be called the interval of convergence. Convergence. So here is a first example, and I'm going to come back to some of those other words there. We're going to do an example. We're going to take this infinite series, and we are going to determine what are the values of X for which it converges. And I am telling you right now, every single time you start this problem, start with ratio test. It's going to work every time. And let me add on that. The only time the ratio test wouldn't work is if you were using the root test to start off with, and the AP test doesn't use root test. And then let me add on, occasionally you can save time if you have a pure blood, not muggle version. Yes, I'm sorry. I am terrible when it comes to Hogwarts. Basically, if you have a pure geometric series, you can go through that avenue and save time. But even if you do, you can still start with ratio test and it works. So always start with ratio test. Make that your main thing. So with ratio test, I am writing limit as n approaches infinity. And then I'm plugging n plus 1 in everywhere that I have an n. And then I am multiplying by the reciprocal of the formula. So I'm dividing by the nth term. You want to remember that the variable of this limit is n. Now, what are you able to cancel? Take a good look. What are you able to cancel?
The x minus 3 to the n. The top and the bottom.
Bam. You got it. So, and then did I see it in my chat? I've got to have my chat ready. Yep, you guys got it. So I have one extra at x minus 3 in the numerator. You don't have to rewrite this limit. I'm rewriting the limit to clarify because I am trying to show to everyone. If I can write, there we go. So you can see exactly what we are doing as we solve this limit. As n approaches infinity, what does n over n plus 1 approach? You're almost there, but not quite. So first of all, just n over n plus 1. What is n over n plus 1 going to approach? You can hold up a finger. Yep. That hint was hold up a finger. 1. So what is the answer to this limit? Because that is the only place you have n. It is moving my mouse away. The only thing I have left is in that absolute values in x minus 3. You know by the ratio test that if this is less than 1, it will converge. While you don't have to write the next bit, I am going to write it right now. And oh my goodness, that's right. I still have it from first period because I didn't get that erased. If it is greater than 1, diverges. If it is equal to 1, it is inconclusive. So that basically means I need to solve this inequality, and the equal to 1 has to be individually checked. The equal to 1 is going to be the edges. So are you ready for a night? Well, you know what? I'm going to start you off with old-fashioned, and then I'm going to show you a neat trick. Maybe you already know the neat trick. This is not the neat trick, by the way, in my opinion. However, maybe you consider it. Never mind. I'm all over the place right now with thoughts. Some of you have that. Okay, I'm sorry, I'm going to sidestep MBTI real quick. Some of you have the personality type where your thoughts are all over the place. And if you are not able to get them organized, they're just going crazy. That's been my whole week this week, with the insanity of actually seeing people and realizing what we have missed. I see what you're saying, but there's actually more. Because having an absolute value less than 1 means that you're between -1 and +1. Take a moment to think about that. And then I add 3. Now here's what I actually like to really look at. This tells you you are centered at 3. Do you see that this interval is centered at 3? Now, because my x is only multiplied by an understood 1, I'm going to throw that out there for the moment. We'll talk about it more later today. This inequality is saying within a distance of 1. Now look at what I wrote for the answer. If you are centered at 3 and you need to be within a distance of 1 from 3, voila. However you solve the inequality, you have to solve it. Then the edges. So one of the edges is when x is equal to 2. Another edge is when x is equal to 4. My ratio test is inconclusive for those specific 2 numbers. So that means I've got to go back to my formula. And plug in those. Okay, don't do this. Okay. I may have to take over my son's laptop and use it to get through the rest of COVID. I had to I had to restart my computer when it started doing these things to get it to stop doing these things because it just got worse and worse. And that's very frustrating. All right, so sigma I've got to write it twice. And then it's an x minus 3. So focusing just right here with x minus 3, x minus 3. Understand that if you are in a free response situation and they ask you for interval of convergence, it might be worth an entire 5 of the 9 free response points, which is an extremely big deal. Know that you have to state, this is the x I'm plugging in. What? Wait, I'm not, oh, whoa, hold on, what's this chat? You should get a Mac. Oh, I see. You're talking about computers. When in doubt, refer back to Lando's chat. And Walker is apparently hurt. Okay, I'm just moving on. It's always fun, though, to interact with people. Okay, let's go. Okay, all right, I'll ignore the whole thing. On the AP exam, you need to say, this is the x I'm plugging in, plug it in. This is the x I'm plugging in, plug it in. You are allowed to simplify as you plug in. But I'm going to show all the steps that might be taken. Now, 4 minus 3 is positive 1. If you have exactly positive 1 to the power of n, what is it? You guys are ahead here. Yep, 1. And now here's another great thing to know. If you are doing interval of convergence on an AP exam, you get to just say converge or diverge at this point, state the test you used, and you don't have to show how you know the test works. The only time in free response that you need to show how a test works is if they specifically ask you to explain how you know, and it's usually going to be a series of just constants. It's not going to be in the middle of an interval of convergence. So you should look at this and go, hey, that's alternating series test, and it is going to be a converging series. And so that's all you need to do. The other one, it's harmonic or P series, if you like. And so this is all you have to write. I will say that you don't have to write these. You can go straight to the simplification. And most people are going to go straight to the simplification. But what I have circled and boxed in green, that must be stated on the AP exam. Right, so that means that it includes 2, but does not include 4. Yep, I'm not using this computer anymore. This is your last day, my friend. Okay, I'm not dealing with you. The answer is inclusive of 2 to 4, non-inclusive of 4. You can write interval notation or you can write inequality. It doesn't matter which one you write. You don't need to write both. If you write both, they both have to be written correctly without making a silly error. So don't. Okay. So that's one example. Here comes example number 2, which is actually example number 1. I switched their order because I wanted to do that one with you first. All right. Next example. We have a new series. Start with the ratio test. And to that question, do they ever ask interval of divergence? No. That would be what you want to think about is, in the past, you've been asked for the domain of a function. They never ask you what is not in the domain. That's kind of awkward. Although it is the AP test, and they'd like to do sneaky, weird stuff. So you're going to start this with the ratio test. Plug in n plus 1. And then divide by the formula. And since I'm not creating a fraction by plugging in n plus 1, I can just do straight up division. And now let's do some math. What cancels? Do you see what cancels? So you have x to the n plus 1 over x to the n. And the factorial. Yep, you got it. So with the factorial, this is n plus 1 times 1 less is n, and you can throw a factorial on the last one you write. Cancel, cancel. And I'm going to write the limit so you can see cleanly what you have in front of you. A lot of people will just at this point answer the limit. But let's be careful with this. If n is approaching infinity, what is the answer to this limit? The answer to this limit is infinity, but hold on. As long as x is not what number? Oh, you were already typing that. 0 times infinity is an indeterminate limit. But any positive real number, positive or negative, any non-zero real number times infinity is going to be infinity. 0 is an issue. But 0 is special in the first place. Look at your series. And I'm going to point to something. Zero is a little extra special. And there's a vocabulary word that I want to try and draw out of you. That is, for this chapter, it's a new vocabulary word. But we've been using it a little bit. When we've looked at the Taylor series and everything, we talked about this vocabulary word. And I'm going to give you a hint. There's your hint. What's special about x equals 0? What the heck? And yep, you're going there. What word do we use for that, though? What vocabulary word do we use when it comes to A? What is special about A? It is the it's highlighted. Center. It is the center. Yes. The thing is, anytime you plug the center into your polynomial, and I'm going to also point out that when the center is 0, this is what you see. So if my center is 0 and I plug 0 in, I only get that constant term, and then from there I'm just adding 0. I will always get an answer when I plug the center in. And then let me point out, if the center is A, when I plug A in, this becomes C sub 0 plus a whole bunch of zeros. So what you need to know is a power series always converges when x is equal to its center. And then I've got another vocabulary word to share with you since it's right here. So, always converges at the center. That means the answer to example 1, which I gave second, is that it converges only at the center, x equals 0. I'll write that down in a second. The next example that I'm going to show you asks you to find a radius of convergence. The word really describes itself. Radius of convergence is the distance from the center of the polynomial to the edge of that interval of convergence. So basically, if you're looking at an x-axis and you're trying to look at what is the domain, you're going to have a center, and it is going to converge for a specific radius, and that radius is this distance. And do you need me to leave it here for a moment? Is it okay if the last problem I just verbally explain the answer? Oh yeah, I found out from my period 1 that I occasionally need to go, are you paying attention? Someone in first period that was present in class today told me that they have a tendency to zombie out while they're online. Because if you're in class, I can see you're zombieing out and I can be like, hey, whoop, wake up, pay attention. But online, it's hard to tell if you're zombieing out or talking to someone else or a hand raised. Yes. Either or. Where did it go? Right here. So as an answer, You can say that it converges at x equals 0, or you can say it converges only at x equals 0, or converges only at its center, comma, x equals 0. But you've got to at least say that much. I should actually warn you that in the textbook, they write the answer as the set of all numbers 0. They use math set notation. Correct. They want to know what is your answer for the domain that x is allowed to be. And so x equals 0 is the most has to get out there. If you just say center and you never specify the number of the center, you're not going to get full credit. But if you have specified the center as this number and then you say converges only at the center, the two come together to make a full statement. All right. Then we are heading into a next example where it asks you to find the radius of convergence and the interval of convergence. Now, if they only ask you for radius of convergence, you are still going to start off exactly the same way. Limit as n approaches infinity, get that ratio test moving. Is it exciting to be on campus?
Yeah, definitely.
Yeah. Being on campus without students was incredibly depressing to me. I hated it when they made us come to campus without students, because I'd come here, be by myself, and be like, this sucks. But at least when I'm at home, I can kind of not feel that missingness. But having students in here, I am overcome. I did not know how much I was feeling until a student walked in the door. And like all these emotions started popping up, and I've just been like haywire all week just from that one thing. Oh my gosh, I would actually really encourage you guys, if you are not in like a dangerous health position, coming on campus is really pretty amazing. You won't understand until you actually do it though. Oh, and I should add that if you're staying home because that means you can't cheat on tests, that's a bad idea. And let me add that if you are cheating on tests, you don't deserve the grade you're getting. You know that. If you have been honest on your tests, no problem. You have earned it. And some of you realize that I'm actually a little bit lenient, because if you come into office hours and get the help you need, I might actually add some points onto your score. Few people come in to get the help, and when they do, they realize what it can do for them. It's valuable. All right, I plugged in n plus 1. Then I multiply by the reciprocal of the formula, and I see what cancels. I'm going to go a little bit quicker at this point because I think you're starting to see a lot of it. The -3, I'm left with 1 in the numerator. For the x's, I'm left with 1 in the numerator. I'm going to rewrite what's here to make sure to be clear on what we're seeing. Do I need to write that negative sign? I don't have to write it because I'm absolute valuing. You can feel free to not write an extra multiplication by negative when you've got absolute value bars. And now, is everyone paying attention? Woo! Paying attention. I'm starting to realize that I actually need to do that. Okay, here we go. I'm recording, right? Thank you. N is approaching infinity. So what is the answer? Take a look. What is happening with this? What is that heading to as n approaches infinity? That's heading to 1. What does that make the answer to this limit? Absolute value. And I see it there. So yeah, there you go. The 3x comes out in absolute values. Then it converges if it is less than 1, diverges if it's greater than 1, equal to 1 has to be checked. But let's take a look at this inequality statement. What is the solution of this inequality? And remember that when it comes to inequalities, you can solve them just like equations with one exception, and that's the issue of dividing and multiplying with negative numbers. There you go. So if I divide by 3, I'm not dividing or multiplying by a negative number. And I'm then getting the absolute value of x is less than 1/3. And the center of this polynomial is 0 with a radius of 1/3. So what you want to be aware of is when you have in your absolute values a 1 times x, an understood times 1 out there. You can have plus a number, minus a number. But once it is x times 1, there's your radius right there on the other side. So know that with the ratio test, what you're ending up getting is an interval of convergence based on x minus the center being less than the radius of convergence. Now, you do have to test the 1/3 and the negative 1/3. At this point, I have that x is between these, and now I have to plug them in. And I need to go back over to the formula. -3 to the n, and -3 to the n, square root n plus 1. And I think it started at n equals 1. Ignore the typing down there. I needed to insert some space. What? Oh, did it? Thank you. And now take a look at what your numerator turns into for each of them. both of those are to the power of n multiplying. What does the numerator turn into? One. It's got to make it extra nerve-wracking to be like two people in the classroom. Let me add some more space in there. So with this first one, when I simplify, I end up with 1 over root n plus 1. And on the second one, what does it simplify to? What is its numerator going to become? Bingo! Yep, -1 to the n. Now that you have those two, now your job is to determine if they are converge or diverge, and for what reason can you say that? So this one, is it converge or diverge? Take a moment to think. Yes, by p-series and comparison, what would you get? Take a moment. There you go. So let me remind you that when you see addition going on, you need a comparison test. You are going to compare it to 1 over root n, and that's a p-series where p is what number? 1/2. And I know you're not an answerer. You're seeing the same thing, right? You're getting those answers. Or, okay, never mind. I won't pick on you. So p is equal to 1/2. That's a diverge. All you have to say is diverges by comparison test and p-series. And it does work for that direct comparison test. Or does it? Hold on, let me think. You know what, I'm gonna get things backward if I start trying too hard because I'm jumbling right now. It may or may not work for the direct comparison test, but it might be the limit comparison test that you need. Okay, for this one, what do you see for that? Yep. Uh-huh. And by the way, Dylan, I know what it's like to be a non-responder person. My personality is in the framework of the person who is a background person, quote, which means that responding is highly stressful, that other people don't even understand the stress level of it. Wait, what did I, oh, alternating series test, converge. And that's all you have to say. And then you can just respond to, this is my interval of convergence. It is, what numbers am I using? I totally, and there we go. Aw. Is Landon one of your friends? Yeah. He mentioned you. He said, you got this, Dylan. We are proud of you. But yeah, I know. It's weird. I don't have a problem teaching, but if I'm in the student setting, it's a different role. And I'm not comfortable with answering questions in the student role. And that understanding has actually been what has partially provided me with the realization that too many people have anxiety under those circumstances, because that would produce so much anxiety for me, I wouldn't be able to actually learn anything. And so, but I also understand other people are needing to respond. So this is where it really helps to have a classroom and I can see you and I can kind of get a feel for where you are and what you need. And I can't figure that out online, except for Jackie. Jackie's like social butterfly. I'm going to answer the question. Doesn't matter if I'm right or wrong, because I know that I have confidence in myself. It doesn't matter what all you think. I'm sorry, Jackie, yes? Jackie just got called a nerd by Taya. Yeah. Mm-hmm. Okay. So the first one we did was this one, and it created an inequality. We got an answer for the first example, which was example 2. We were able to get an answer to this limit. This one, the second example that was example 1, the answer to that limit was literally infinity, except for 0. Because when I put infinity in and think about that limit, infinity times anything other than 0 is infinity. And so, okay, so what you're looking at is the answer to the limit. That's your key. Answer to the limit. When you are looking at this limit, you have infinity times whatever x is your actual answer. And unless x is 0, that's infinity. That is the answer. Right. Yep. Excellent. And other people thank you too, because I know we background people depend on you people who are comfortable talking. And then if you don't talk, we're screwed. Oh yeah, you're highly appreciated, believe me. So if n is approaching infinity, let me just point out, that's the variable of sigma. X is not the variable of sigma. It just sticks around going, hey, like that. Now, actually, before I go on to the next example, which is an interesting example, you have at this point had enough to be able to understand what you need to do. And I need to grab something that I forgot to paste down here. No, okay, just down. There we go. Because I need my textbook, which I forgot to open during. Okay, now textbook. There we go. There's one thing I forgot to pull out as a clip. Let me just see where I'm at. Further. There we go. Okay, this theorem and then a chart coming up are important. You recognize this formula right here. You should definitely recognize it. We've used it. There are three possibilities when it comes to where does it converge. One possibility is that it converges only at the center. Another possibility is that it converges for all x, which we're going to see what that looks like if we have time. The third possibility is that there's a positive number r, not 0, not infinity, but a positive real number, for which you get this inequality. And when you have that x times 1 over there, this is your radius of convergence. And you get that you know that it converges for less than r, you know it diverges for greater than r, the individuals have to be checked. Now I'm going to, and this is in your textbook, I'm going to scroll. There's a lovely picture right there, but this table's really, really valuable. And we have done example 2 and example 1, and I'm about to do example 3 that will show you the other situation. I also put another example ahead of it because I felt that was very valuable to do. So for the very first problem that we did, that was example 2, we actually got that the radius was 1, and this was our answer. For the second example we did, we got it that it converged only at 0, and this is the way that they write it, which means the radius is 0. The radius of convergence is 0. But sometimes we actually get that it just flat out converges no matter what x is. And in that case, if you're asked for the radius of convergence, know that it is infinity. And then the interval of convergence is just everybody, negative to positive infinity. So now I've got one last example in 2 minutes, and I will tell you that this is really cool. You should take a look at this. The Bessel function, you're looking at an order 0 Bessel function here. Power series are very powerful. Let me point out the year here. Do you see the year frame in there? We didn't have computers. They depended even more back then on power series than we do now, but we still actually do depend on power series. And this model, this shows a 1 moment 2-dimensional cross section of a drum vibration. Is that pretty cool? That can be written as a power series, but we're only looking at the most simple of them. Now, it's asking you to find the domain of the Bessel function. So let's do that. You're going to write limit as n approaches infinity, and then you're going to have the n plus 1. And then you're going to multiply by the reciprocal of the formula. I missed a lasso. Darn it. Okay. I'm going to have to go to the textbook because I'm out of time. So here's where the textbook does the Bessel function. And what you want to see is this is what happens after you simplify. There are absolute values around that, by the way, but do you see that we don't actually need them? This is what it will simplify to if you go through the work of it. If you're looking at the limit as n approaches infinity, X is representing a real number. N is heading to infinity. X does not get to represent infinity, even though we say its domain is negative to positive infinity. X only gets to represent a real number. And if you have a real number over infinity, your answer is 0 flat out. And if the answer to that limit is 0, 0 is always less than 1, thus it always converges. I don't know what L was for. And then big time, what? Okay, got a quick question that may or may not be pointless. Have we covered in what context? At this point, and all you're going to get from this unit is the issue of converge diverge is the domain of a power series. Power series are functions, but they are no way near the kinds of functions you're used to dealing with. And every time we do functions, we need the domain. We need to know what domain can I use this function for. The interval of convergence tells you the domain that you're allowed to use for that particular power series.